I'm going to start a new discussion. Here I will be discussing about the cells connected in series. We'll take first of all three cells connected in series. Okay. This is of EM of E1, internal resistance R1. EM of E2, internal resistance R2. EM of E3, internal resistance R3. Okay, this is point A and this is point B, right? Now let us take this point as C, this point as D. Okay. Now they are connected in series. Now you can see this is the direction of current in all these things. As they are connected in series, current is same. And as you can see here that current is directed away from the positive terminal, which means the cells are discharging. Okay. Let us write the potential difference between A and B. VA minus VB is what we need to find out. This is equal to VA minus VC plus VC minus VD plus VD minus VB. Am I right? VA minus VC plus VC minus VD plus VD minus VB. What is VA minus VC? A and C are the terminals. If you look at this cell, A and C are the terminals of cell 1, which means I can write this as E1 minus IR1. Ready? Now C and D are the terminals of second cell, which means I can write plus E2 minus IR2. Similarly, D and B are terminals of cell 3, which means E3 minus IR3. Ready? E1 minus IR1 plus E2 minus IR2 plus E3 minus IR3, which means that is equal to, we can rearrange this as E1 plus E2 plus E3 minus I into R1 plus R2 plus R3. Ready? Now, what do you mean by equivalent EMF of a cell? Equivalent EMF. Now let me replace this cell with this combination with a cell of effective EMF E effective and effective internal resistance R effective. Then I can say that this is again A, this is B, and the same current I flows, means the left side of this equation becomes E effective, right? Look at this, VA minus VB. Now in this case, A is one terminal of the cell, B is the other terminal of the cell, and again it's a discharging cell because current is directed away from the positive terminal. This is equal to E effective minus I into R effective, right? So E effective minus I into R effective is equal to this side. Now comparing the coefficients of various terms on both sides, you can see that E effective is equal to E1 plus E2 plus E3, that is these two terms. And what is going to be R effective is equal to the coefficient of I here, coefficient of I there, that is equal to R1 plus R2 plus R3. So E effective is equal to E1 plus E2 plus E3, R effective is equal to R1 plus R2 plus R3. That means when cells are connected in series, the effective EMF is equal to the sum of the individual EMF, and effective internal resistance is equal to the sum of the internal resistances. So that means now we can generalize this. If you connect a number of cells then we will get E effective is equal to E1 plus E2 plus etc. plus En, and R effective is equal to R1 plus R2 plus etc. plus Rn. This is the answer. If you connect n number of cells in series, E1, E2, E3 etc. are the EMF of each cell. R1, R2, R3 etc. are the internal resistance of each cell. This is the answer we are getting. If from here, if E1 is equal to E2 is equal to etc. is equal to En is equal to E, R1 is equal to R2 is equal to etc. is equal to Rn is equal to R. My question here is going to be, what is E effective is equal to? E effective is going to be equal to Ne, and R effective is going to be equal to N small r. This is the answer to understand. This is the answer when N cells are connected in series. Okay. Now let me discuss a question. This is a very recent question, I have to say. Yes. All cells are identical. Now this is a question I am discussing. This is a very relevant question because the same question asked for Kerala Engineer Examination 2020. Okay, this is a question I am discussing now. See, the EMF of each cell is C. The internal resistance of each cell is smaller. Now look at here. Okay, let me put. You are asked to find out what is the reading of the voltmeter. What is the reading of the voltmeter? Let me call this cell 1, 2, 3, 4, 5, 6. You can easily understand that the reading of the voltmeter is where is the voltmeter connected? Voltmeter is connected between these 2 points, which means voltmeter is connected across the terminals of this cell. Let me call it as A and B. So A and B are the terminals of cell 3, right? A and B are the terminals of cell 3. Now the question is, what will be the reading of the voltmeter? Reading of the voltmeter will be, okay, let me arbitrarily take the direction of current. If what I am choosing is right, then I will get positive value of current. If the direction which I have chosen is wrong, means the value of the current I am going to get is negative only. So here is going to be, so in this case I am saying cell 3 is discharging, which is E minus I into small r. Ready? Okay. Now my requirement is to calculate the value of I. Once I get the value of I, the problem will be over very soon. Now see, this is a very important question, very tricky question. Look at, okay, let me take a cyclic operation. Here the current is from negative to positive. 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 Here the current is from positive to negative, right? The current is from positive to negative. Here also the current is from, this figure let me modify. This current is also from positive to negative. Okay, so let's take H1, D, Such likewise we can say. Now here, look, 1, 2, 3, 4 cells are connected in the same order, whereas the remaining 2 are connected in the reverse order. Understand one thing, that you may be asking me a question, sir, when current I comes here, won't that be flowing through this voltmeter? Answer is no, because voltmeters are generally considered to be of infinite resistance. That means it is like an open circuit. It is like an open circuit. It is like an open circuit, which means no current will flow through the voltmeter. So whatever current I comes from here, that current I will be flowing through this branch only. Now see, 4 cells are connected in same order. E, 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 E. 2 cells are connected in the reverse order. Let me first of all take what is E effective is equal to E plus E plus E plus E, which is this 4 is E, 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 E. These 4 cells are connected in the same order, that is why I have taken it as positive. Now E1 is equal to, here I tell you, E1 is equal to E2 is equal to E3 is equal to E3 is equal to E6, not E4, that is equal to E plus C. Now E4 is equal to E5 is equal to minus E, because why? It is connected in the reverse order, right? It is connected in the reverse order. So I will say this is equal to minus E. Come on now. So E effective is equal to, let us take this equation, E1 plus E2 plus E3 plus E4 plus E5 plus E6, because they are all connected in series, right? They are all connected in series, so E effective is equal to E1 plus E2 plus E3 plus E4 plus E5 plus E6. Which means this is equal to, get me the answer, E1 is equal to plus E, E2 is equal to plus C, E3 is equal to plus C, E4 is equal to minus E, E5 is equal to minus E, E6 is equal to plus E. Hope it is clear to you. These two are connected in the reverse order. Positive, positive. In all other cells, positive is connected to the negative. Here, positive is connected to another positive. That is the reason why it is reverse order, right? So, what is the answer? That is equal to, yes, 1, 2, 3. E plus E plus E, 3E minus E, 2E minus E, E plus E, 2E. When 2 cells are connected, so there are altogether 6 cells. When 2 cells are connected in the reverse order, the answer is 6 minus 2 into 2, that is 2E. 2E. Now, effective resistance R effective is equal to 6R. You may be asking the question, sir, why don't you consider negative for this? Resistance has no polarity. Cell has a positive terminal, negative terminal. Resistance has no positive terminal, no negative terminal. So R effective is equal to 6R. Then my question, what will be current I is equal to, we have direct formula, E effective divided by R effective. That is the current, because there is no external resistance here. That is 2E divided by 6R. That is equal to E by 3R. So I is equal to E by 3R, or IR is equal to E by 3. Now this is the equation. So let me take this as equation number 2. Let me take this as equation number 1. Substituting equation 2 in equation 1. Therefore, terminal potential V is equal to E minus E by 3. That is equal to 2E by 3. The terminal potential here is going to be 2E by 3. And the problem is over. In this year's question, the value V was given to be equal to 5 volt. Then your answer will be 2 into 5, 10 divided by 3 volt. 10 by 3 volt. 10 by 3 volt is the answer to this question. 10 by 3 volt. Ready? Answer is 10 by 3 volt. That is an important thing to understand. Okay? Clear? Now, based on this question, I can say one more idea. Okay. That is my last question for the day. This is homework for all of you. Homework. N cells each of EMF are connected in series. EMF E and internal resistance smaller are connected in series. Out of n cells, if k cells, the bracket k less than n, are connected in the reverse order, comma, find first one effective EMF. Second part, effective internal resistance. Third part, effective current. This is a homework for you. I expect everyone to solve this question and get me the answer. Thank you.